Hello friends, you are all welcome to this video. Today in this video we will study the volume of a right circular cone.
Look, my mother has brought me this unique shaped vessel.
It is a right circular cone. How much water can you fill in this, Thomas?
I don't know. If it was a right circular cylinder, I would have answered it quickly. But how can we find the volume of a vessel that's in the shape of a right circular cone?
It is very easy. Let me teach you the formula of volume of right circular cone by using the volume of a cylinder.
Hey, wow! That means it's math time!
Thomas, can you bring a cylindrical vessel whose height and radius of the base are equal to this right circular conical vessel?
Of course, I'll bring it right away. Here, take this, Manas.
Thomas, now we will first fill this long circular conical vessel completely with water up to the brim and pour this water into this cylindrical vessel. Look, Thomas, some part of the cylindrical vessel has been filled with the water. Now we will again fill the conical vessel completely with water and pour it into the cylinder. As you can see, the cylinder is still not fully filled. Now we will fill the cone with water for the third time and pour it into the cylinder.
Hey, look! The cylinder is completely filled with water.
Yes, Thomas. So we can conclude that the volume of 3 cones is equal to the volume of a cylinder. This means if the radius of the base and the height of the cone and cylinder are the same, then the volume of the cone is 1/3 of the volume of the cylinder. And you know that the volume of a circular cylinder is equal to the product of the pi square of r and h, where r is the radius of its base and h is the height. Therefore, we can write the volume of the right circular cone as 1/3 of the volume of the cylinder, where r is the radius of the base of the cone and h is its height.
Hey, wow! Manas, let me quickly write the formula for the volume of a right circular cone in the formula book.
Thomas, because the thickness of your conical vessel is very small, we can treat it as negligible. The amount of water that is encased in this conical vessel will be equal to its volume. So, now we just need to find the radius of its base in the formula for this right circular cone. The radius is 3 centimeters and its height 14 centimeters. So, let us solve this by replacing the numbers at the places of r and h respectively. And then we will know the volume of this right conical vessel.
The volume of a long circular conical vessel is 132 cubic centimeters. And we know that 1 milliliter is equal to 1 centimeter cube. Therefore, we can say that 132 milliliters of water can be filled in this right circular conical vessel.
Let us go back to our world, Thomas. Then, as a way of thanking your mother, we will set ice cream for her in this conical vessel.
In this video, we studied the volume of a right circular cone. We learned 1. What is volume? 2. How to find volume of a right circular cone. In the next video, we will see some interesting examples based on this. Hello friends, we welcome you all to this video. We had studied the volume of a right circular cone in the previous video. Now, in this video, let us look at interesting examples based on volume of right circular cone.
Look, Thomas, a new building is being built here.
Yes, Manas. Look, that uncle just poured a sack of sand on the floor. And if you look closely, you will find that this sand is making a cone on the ground.
Yes, Thomas, this is really conical in shape. Can you tell me approximately how much sand was in the sack?
It's so easy. Let us find the answer through mathematics.
That means it's math time!
Look, Manas, Uncle has poured a sack full of sand on the ground. It's a conical pile of sand. And you already know that the space enclosed by any object is equal to its volume. This means that the amount of sand in this pile, or in other words, a sack, is equal to the volume of the pile of this conical sand.
I remember the formula for the volume of a cone. The volume of any right circular cone is 1/3 the product of pi square of r and h, where r is the radius of the base of the cone and h is its height. But Thomas, this is a difficult one. We can see that the height of this sand pile is perpendicular to its base, so it is a right circular cone. And we can also find the radius of its base by measuring the diameter of its base. But we cannot measure its height. So, how can we find its volume?
Don't you remember, Manas, that according to the Pythagoras theorem, the square of the diagonal height L of any perpendicular circular cone is equal to the sum of the squares of the radius of its base R and the height h.
Oh yes! And we can measure the diameter of the base of this conical sand pile and also the slant height. Let me quickly measure them. The diameter of the base of this conical sand pile is 42 centimeters and its slant height is 29 centimeters.
Because the diameter of the base of the conical sand pile is 42 centimeters, the radius of its base will be half of 42 centimeters. That is 21 centimeters. Let us now replace L as the slant height and R as the radius respectively. The slant height of the sand pile 29 centimeters and the radius of its base is 21 centimeters. Look, Manas, we should solve it in this way and find the height of the conical sand pile. Got it? The answer is 20 centimeters.
Oh wow! Now let me quickly replace R and H in this formula respectively. The radius of the conical pile of sand is 21 centimeters and we solve to get the height, which is 20 centimeters. Thomas, we got our answer. A bag of sand has 9,240 cubic centimeters of sand.
Well done. Now let us return to our world. Then we will go to play at your house.
With this example, we have seen how our daily life problems can be solved based on the volume of a right circular cone. In the next video, we will see an interesting example based on this. You are all welcome in this video. In the previous video, we have seen an interesting example based on volume of a right circular cone. Today, in this video, we will see some interesting examples based on volume of right circular cone.
Thomas, why have you dug up this huge conical pit?
I made this to feed the birds.
Oh, wow! But how much water can you fill in it?
Let's try to find out. We can find the answer through mathematics. It's math time! Look, this pit is conical in shape. The amount of water it can fill is equal to its capacity. And its capacity will be equal to the internal volume of the pit. Therefore, we only have to find the internal volume of the pit.
I can quickly find the answer. The upper diameter of the conical pit is 12 centimeters. That means its radius is 12 divided by 2, which is 6 centimeters. The depth of the pit is 20 centimeters, which is also equal to the height of this conical pit. And as you know, because the height of this pit is perpendicular to its base, we can say that this pit is a right circular cone. Now, all we need to do is replace the values of the radius of the right circular cone r, which is 6 centimeters, and its height h, which is 20 centimeters, in the formula for the volume of a right circular cone.
Look, Manas, the internal volume of the pit is 754.28 cubic centimeters. And we know that 1 centimeter cube is equal to 1 milliliter. Therefore, we can say that the capacity of the pit is 754.28 milliliters.
That is a lot of water. Thomas, let us quickly return to our world. By now, many birds must have gathered to drink water from your pit.
Both the friends were very happy to see many colorful birds drinking water from Thomas's pit. Friends, in this video, we saw an interesting example based on volume of a right circular cone. So hopefully you will now have a good understanding of the volume of a right circular cone.